Welcome back. We're writing Little Man Computer in C++, and we've just started the process of working out, iterating through a file of assembly language instructions and converting them into the relevant data structure for further use. So we'd got as far as, let's have a look in our tests here. So we've got as far as having just a single halt instruction, but we've set it up in such a way that we have this dummy input stream, and we create an assembler and parse the instructions from that stream. So we've just done a single instruction for now, and what we kind of want to do is to take the next step. Well, there are two directions to go here. If we look at the production code here, we can see that what we're doing is that we are just returning a fixed constant value, and what we want to do is to either the direction we can go is we can either work out looping or we can work out parsing instructions, but the looping kind of is requiring parsing instructions to work anyway, so it would seem sensible to take the next step of moving away from a fixed value to a calculated value in here. So if we create another test that's a bit different. Oops, didn't mean to do that. If we create another test that is a little bit different to this one. So let's just delete all of that. So we want an input stream with a single, say, input instruction, creates the correct instruction vector. That's a little bit of a vague result, but I think that's fine for now. We can just do this, and we can expect this result, like so. That should fail, and I think we'll be able to, the simplest way to make this pass will be just to be parsing the instruction, which we already have a method for. So we will do that in a second, assuming this fails correctly, which I'm hoping it will do, and indeed it does. So we should be able to make this pass by going here, and if we, instead of that, we push back the result of what's the correct way of calling our own things here? I guess we can do assembler parse instruction. This is going to be the wrong format for calling it, I would imagine, but we'll find out in a second. And then that would be let's just do this in two slightly separate sections. We want oh, this is going to be awkward. No, I think we're okay. So we want a string, which is the line of the file, and then that string is going to be getLine input stream line, and then let's do it slightly multi-step here. So our instruction is going to be equal to parse instruction line, like so, and then push back is, that's not quite what I intended. Pushback will just be the instruction. This may not quite do what we wanted to do. We will see in a second. That's certainly not doing exactly what I wanted to do. getLine, is that the right? getLine in file and line. requires string getLine. I'm sure we're using getLine already further up here. Oh no, we're not. We used to be, but we're not anymore. So getLine string. So we might need to include a little something. IOStream, I guess, as we are already including string. I thought we were including IOStream in the header file, actually. Let's check that. We are indeed including IOStream and string already. That's kind of interesting. So what does that mean? We don't need IOStream here. So getLine is not quite doing the right thing. Am I using the wrong formulation of it? Takes an IOStream and a string reference, which seems to be correct here. What is the no matching function call to getLine on this line here? That's interesting. We're including IOStream and we're including string. So what is the issue? std getLine with a stream and a string. Sounds like it should work. So there's a string, and we've got a stream. We can get rid of that. Shouldn't make any difference. No matching function called to getLine input stream line. Does it say what it is expecting in any of these? Candidate template ignored. First parameter does not match adjusted type const IOStream. So is the issue that it's a reference? That's kind of interesting. So if I do that, and in here, the same, does that make the problem go away? Candidate function template not viable, requires 3 arguments. No. No matching, blah blah blah. First parameter does not match the adjusted. Okay, const basic IOStream char. Deduce type basic IOStream that. Sometimes I find these error messages a little challenging. Let's go back to what we had before. So that was sort of working on the string split, but for some reason doesn't want to work here. So what? Let's go check here. So we want an IOStream. Is it because it's const? Is that the problem? Are we modifying the IOStream? That's the only thing I can really think of being the problem. Let us see if this fixes the issue. That looks better, doesn't it? So it doesn't want to be a const. That's fine. I can live with that. And we'll see if that passes the test, which hopefully it will do. And then we'll see. Yep, that's fine. So then what we want to do is we want to go and add a test that gets us somewhere near having multiple instructions. Input stream with an input and an output instruction creates the correct vector. So here what we want to do is something like that. So a reasonable approximation of what we're looking for. And now we are looking for this as the result. And that should fail in some interesting way. Should just fail in this case in a not matching the result by size. Yep. And hopefully we can make that pass by wrapping this in a while loop. Should hopefully be all we require doing. Oops. So does that look right? We create a line to put things in, we loop over get line, we create an instruction and then push it into our instructions list. I think that seems okay, doesn't it? So does that make the test pass? Well, it compiles, that's a good start. And hopefully this will get us to the right sort of point. And indeed it does pass, that's excellent. So the last component part of this that we want to deal with is to handle the case where there is a comment-only line, like so. Output instruction, we don't need to know all of that, with a comment-only line creates the correct instruction vector. So if we then were to put in the middle of this another line that says is a comment line, what we would hope is that that would not in any way change the result, but I think it probably will. It will give us 3 instructions, one of which is completely blank. So this should build fine, and then it should just fail on that last test. So what we'll need to do in the production code is just to simply filter out those instructions that have been parsed where all 3 component parts, the label, the opcode, and the address are empty. Now this is interesting. I wonder if that's... I'm sure we did something like this. This occurred before. Set a breakpoint in malloc error. That's quite a confusing error message. So what's it doing here? I'm assuming. I wonder if the parse instruction is struggling in here because this comment only line is causing us not to have 3 tokens when we split, which seems likely, doesn't it? So how do we deal with that scenario? I think what we want to do is we want to back out that test that we've just written and write a different test. We'll do it via comments for now, and write a different test further up to handle the single comment line not doing something that we don't want it to. So here we've got comment only line is correctly parsed. So what we want that to be is if we have a line that is just that, we kind of want to return a blank result. Now I think this will also come up with that unfortunate error message, but it should be relatively straightforward to fix by checking the number of component parts in our parse. Hello, what have we got here? Comment only line is correctly parsed. That's interesting, isn't it? So why is that? So what's our split doing? If we go back here to the production code, our split into comment and code is splitting on double / and should, in principle, be leaving us with two parts. I'm going to do a slightly naughty output mechanism here just temporarily that outputs the first item here so that we can see what's going on in between each of the tests. This is just a very brief temporary thing. So it's just before the comment only line is correctly parsed output, or in between the output and the parse, we should have some sort of debug which tells us what it thinks is going on. That's interesting. Can't allocate. So this is a similar problem. I guess we need to do something like if code and comment dot size is greater than 0, perhaps. Don't know if that will make any difference, or whether we've just horribly broken lots of things somehow just by putting that debug statement in. We shall find out in a moment. It's kind of interesting. I wasn't really expecting that kind of result. So now the comment only line is correctly parsed is causing it to die. We can see the component parts being presented. These are tabs, which is why it's a bit wider. So for some reason this didn't work as intended. I wonder if there was a not saving issue in some manner, and if I rerun this now without the debug code, it'll actually crash on the comment only line test, and we shall see what it does. But yeah, parsing was completely unexpected there. I would not have expected that result. Okay, so now it's failing. that we must have not saved something somewhere. So that's fine. So we can now make this work slightly better and say if our tokens size is less than 3, we can do this, else we can do this. I think we can do this directly like so. I will check that in a second by running the tests. If that's the case, I might simplify the other version as well, as it looks a little nicer. There might be other places we can make that simplification as well. We won't worry about that for the time being though. Let's get the tests passing first. So now we've got 5 failures, which is interesting. So, what have we done wrong there? So, comment only line is correctly parsed, fails anyway. So, tokens.size is less than 3, which is our requirement. Ah, yes. Then we should have done the other item there. So that should be this. And we don't need any of this stuff. So I just had the check the wrong way around. Well, the check was the right way around. The content was the wrong way around in that if statement. So let's see if this rectifies the problem. But it looks like the comment line is correctly parsed opposite fail pass value might suggest that these are going to actually pass correctly. Oh, it's gone even worse now. So what's happened here? Although the comment only line is correctly parsed is correct now. And most of the other ones are broken. So if our token size is less than 3, we want to just return that value. Otherwise, we want to return this value. But for some reason, that does not work at all. I wonder why. Let us temporarily go back to something we think works on all but the comment test and have a look. This would all be a lot smoother, of course, in a language that I was fluent in. But the aim of this exercise is primarily for learning. So something has gone wrong that I don't understand on these tests. Halt instruction with no label. So we've broken something quite badly. And the question is, what? I wonder if I've... Let's go back to the test and see if I've done anything that's broken things in here. If I were to, for example, comment this test out, does that fix any issues? Would be kind of interesting if it did. Can't allocate region. It's possible that works. It's possible that we're encountering some sort of memory size limitation on the way we're allocating our variables. And that might actually be the issue here. That would be kind of interesting, wouldn't it? So we might have made this test vector too big, potentially. So how would we get around to that if that's the case? That is an interesting problem. So this is currently just allocated directly here, like so. I wonder for a start if that would be better off as that. Does that work? Rather than an assignment and a copy, potentially. I'm not precisely sure on my memory management stuff. It seems to be happy with that, and the test still passed. Let's do that for the other ones as well before we move on. So that's the assembly tests, the man tests, and the computer tests, I guess. Like so. Let's just do that. It's starting to feel like that's a memory allocation problem in terms of the space, and we might have to move to properly allocating some memory here. Yes, this is starting to get a little flaky here. What is the best way to deal with this problem? This is somewhat independent of the test we're trying to make pass here as well. It's possible this can be addressed in the compiler, but I don't really want to do that. One option would be to break up the test classes. Into multiple classes. Which wouldn't be ideal. So have we left the other code in a fit state? Let's delete that. Let us see what our status is. So we've changed those things. So we've just updated the parse instructions function, made it not const, and then everything else is in our assembler tests. Okay. So we may need to do a different kind of allocation here, but I'm not sure there's a nice way of doing that. Are we consistently now overflowing our memory, or is it inconsistent? Let us examine. No, it's fairly consistent there. I wonder if we temporarily disable the computer tests and little man tests, if that will give us some breathing room to work. before coming back, so we can get to a working state and then come back to fix the memory problem after we're in a nice place. So that's got one failure. Input stream with an input and output instruction creates the correct instruction vector. Did we break that in some manner? I'm also going to temporarily remove these tests as well. Like so. And then we'll just get back to finishing off the problem at hand before we go and fix our memory issues. Now we've got 3 failures. Have I commented out something important in between? That's our man tests. That's our computer tests, and I've not commented out anything that we didn't want commenting out. It's interesting that the existence of those tests is affecting the result of these tests, which I wouldn't expect to be the case. Let's do that again. Now they pass. Is it inconsistent? Now they fail. Oh no. That's not nice, is it? Alternating passing failure. I wonder what that's all about. There must be some global state that it's playing with here that breaks things, but I don't know what that would be. Let us just put these back and fix the problem. I don't like operating in this situation where we've got flaky tests. So we've got a number of different things to rectify. So that we know what that problem is, we can deal with that. So that is the case here, where tokens size is less than 3, and then we can just return an empty instruction like so, and subject to any flakiness in the tests, that hopefully will pass. And then we will complete the yeah, I think that's our intermittent failure here, because that change I wouldn't have expected to break things. No, that's consistent. That's consistent, but it's breaking a bunch of other things that I wouldn't have expected to be broken. But there we go. So if token size is less than 3, return that. Is that not the right way of? Well, it shouldn't matter if that's the right way of returning, because there's only one. There's only one case where that actually should have a value. Interesting. And let us let's try that again. Now we've got a random 2 failures. No, I'm not happy with this. So what I'm going to do is I am going to hard reset that and return to a second attempt at it after fixing memory problems. So is it just this? Yep. And we're back in the position we were before. Let's just quickly check what we're doing here. That's all fine, isn't it? Okay, so that was an interesting journey, which we will retrace again in the future once we've fixed our potential memory problems next time.